Hello, chemists. The first part of this video, we're going to take a look at the periodic table. This is our type 3 naming, which a lot of chemistry instructors call type 3. These are for covalent compounds, so these are non-ionic compounds. So covalent compounds. Both the type 1 and type 2 naming were both ionic compounds. Those were metals and nonmetals. For this one, we are going to work with only nonmetals. So what I'd like you guys to do is pause the video for a second and mark all the nonmetals on your periodic table. So pause it, and then when you start up, you'll see where I mark all these nonmetals. Okay, nonmetals are here. This general area. These are all the nonmetals. And don't forget, hydrogen over here is also considered a nonmetal. And for naming purposes, we also include the semimetals. So just for this, the naming of semimetals is usually the same as for nonmetals. So all of these we consider covalent compounds. And those are, it's really important because instead of a metal being the first shown in the compound, it's going to be a nonmetal. So the rules are down here. First, all the atoms in this molecule, so the first one in all of them are nonmetals. So if you look down here, sulfur is the first one here, carbon's the first one here. So if you see the first atom in a compound is a nonmetal or a semimetal, you should assume it's going to be, or conclude it's going to be a type 3, this kind of special naming. And if you were wondering, when are we actually going to get to use these Greek prefixes? Well, now is the time. So you should memorize these 10. Mono is 1, tetra is 4, nona is 9. So these actually tell you how many of each atom. So we use these prefixes to say how many. We don't look at charges at all. We just say how many of each atom using mono, di, tri. And one exception to that would be in compounds like this. You don't use mono if the first atom is just 1. That one you'll just call it the name of the atom. Okay. So let's get started with a few examples. This first one has 2 sulfurs and 4 fluorides. We still change the end name of fluorine to fluoride. So because there's 2 sulfurs, and because sulfur is a nonmetal, we're going to use this nonmetal naming, and we'll call this disulfur. Tetra is 4 tetrafluoride. So we keep the same name for sulfur, but there's 2 of them, so we use the di prefix, and then there's 4 tetra. So we use tetra for the 4 fluorine atoms. We still change the N to IDE. So for this second one, there's 1 carbon and 1 oxygen. So we don't use a mono on the first one, so we just call this one carbon and then monoxide. So you might think, well, why don't I say monoxide? Whenever there's 2 O's next to each other, we just get rid of 1. And we call this monoxide. So carbon monoxide, you should have heard of that. It's a silent killer, very dangerous molecule. And that's much different than this one, which we've all heard of, has a single carbon and 2 oxygens. So C would be carbon dioxide. Again, there's a nonmetal first, so that's why we use this naming system. It's much different than the ionic molecules. For D, it looks like we have 2 chlorines and 7 fluorides. So this one is going to be dichlorine. The first one keeps its same name. And then 7 is hepta up here. So dichlorine heptafluoride. So I gave you a little clue on E. I highlighted this one for a very, very specific reason. A lot of students will call this aluminum trichloride, but remember, aluminum is a metal. it's right here. Aluminum is definitely not a nonmetal, it's a metal. So this goes back to our type 1 naming, and we simply say the name of each ion. In fact, this was the first one on your activity. This one is simply aluminum chloride. So it's really important that you give the correct type of naming. So this is a type 1 metal, nonmetal. So we just call this aluminum chloride. There's no Roman numeral in the name. I'm just saying it's a type 1. So it's not aluminum 3 chloride or aluminum 1 chloride. It's just aluminum chloride because we know the charge of aluminum is +3. For these next examples, I put a semimetal in letter F here. So a boron and 3 bromides is just going to be boron tribromide. And then for the letter G, it looks like we have all sorts of nonmetals. So some new students might say, oh, here's nitrogen, tetrahydrogen, monooxygen, monohydride. That sounds like a horrible amount of naming. So this is why we were so deliberate about giving names to our polyatomic ions. So NH4 is definitely the ammonium ion. So this one is actually a type 1 as well. It's got the ammonium ion. And then the OH minus is the hydroxide ion. So we literally just name each of those ions, which is why we work so hard to memorize those because they show up all the time. So ammonium hydroxide, we're just naming this positive ion ammonium, the negative ion hydroxide. And the last one here uses a noble gas, which typically don't form bonds, but this one does. So here we have xenon and then 4 oxides. So this is going to be xenon tetraoxide. And in fact, if the A and the O are next to each other, we just say tetroxide. So a little bit of a subtle rule that if you have two O's next to each other or an A and an O next to each other, we just leave the O. And so we say tetra, get rid of the A, so we just call it tetroxide. I hope this helps, and I will send you this worksheet, and then we'll have plenty of practice to do. Good luck.